Welcome, ladies and gentlemen, to the second segment of systems of equations using the substitution method. We're looking for the point where these two lines are going to intersect. So first of all, we need to determine whether these two lines have different slopes. Let's see. Now remember, the basic form of looking at the slope is minus a over b. So let's analyze equation 1 first. This case, a is 4, b is negative 1. So let's check out the slope. So now for equation 1, the slope is minus 4 over that negative 1. But now we have negative times a negative is positive. So therefore, we know that the slope is equal to 4. So the slope for equation 1 is 4. Now, for equation 2, a is negative 2, b is 3. So, let's check this out. The slope for equation 2 is equal to minus a, which is a negative 2, over b, which is 3. Well, now I get a negative times a negative. Well, in this case, the slope for equation 2 is 2/3. And voila, ladies and gentlemen. Since these two lines have different slopes, what conclusion can you draw? I'm waiting. Yes, that's the conclusion that you can draw. We know that if two lines have different slopes, they are going to intersect, are they not? Very good. You're a good student. Now, let's move on to the next step. Let's utilize substitution. So first of all, I'm going to ask you to pause the video, copy what I've done here so far. So I'll give you a few moments. I'll move out of your way. Pause the video, please. All right, ladies and gentlemen, welcome back. Welcome back. Okay, now we want to use the method of substitution. What equation do you want to use? Because we need to solve for y for one of those equations. So what equation are you going to use? Which one do you think would be easier to use? Do you want to hear what I think? Are you sure? All right, well, I'm looking at equation 1. You want to know why? Because the only thing I have to divide by or multiply through is by a negative 1. So I choose to solve for y using equation 1. So let me write down equation 1, and then let's solve for y. So now for equation 1, I have 4x minus y. That's equal to 16. Now I need to get the y by itself. So where do I start to do that? What is the next thing I need to do to get this y? The y expression in a term by itself. What has to go? We're on the left side of the equal sign. What would you do to get this y by itself? What do you do now? Marvin, what do you think? That sounds good, John. Do you agree? Do you agree? They said they have to use the additive inverse of that 4x. What is the additive inverse? George, what is the additive inverse of 4x? Good man. What about you? Yes, the additive inverse of 4x is negative 4x. So what I'm going to do, I'm going to add negative 4x, the additive inverse, to the left side. Now, by the additive property of equality, whatever I add to one side of an equation, to maintain our balance, I must add the same thing to the other side. That is called the additive property of equality. Say it with me. The additive property of equality. Very good. So I'm going to add negative 4x to the right side. Now, when I do that, these expressions cancel. Cancellation law. Additive inverses cancel one another. Now I have negative y is equal to. Can I combine those two terms? Can those two terms be combined or added? If they cannot, please tell me why. Harold, what do you think? Can I add these? Can those two terms be combined? Justify your answer. Can you tell me why they cannot be? Yes, you're correct. They cannot be combined because they are unlike terms. This is a numerical coefficient. It's a regular number. That is a variable expression. Before we can combine these, I would have to give you some value of x. This means -4 times x. I would need some value of x to multiply by 4. Once I completed the multiplication, then I could combine those. But since I don't know what x is, that's an unknown expression. It's a variable expression. I cannot combine those two. Excuse me. So now I end up with -4x plus 16. Is that y by itself yet? Is it? Look at it closely. Is it by itself? Do I have y equal? If it's not, what's wrong with this picture? What did you say? Marvin? I heard you right, yes. When there's no number here, it's understood to be 1. Well, that's a -1. I need to get rid of that -1. How am I going to do that? Patrick, what do you think? Yes, I can divide each term by -1. Let's show that on the next line. So now, dividing each term by -1, I get -y divided by -1 equals -4x divided by -1 plus, I get 16 divided by -1. Negative over negative, that's positive. Is that correct? You see that? So now I have y equals negative over negative is positive. That gives me 4x. And then a positive divided by negative, that gives me -16. All right? Now, before I move on, now for this one, for equation 1, it's easy to find the y-intercept. When x is 0, y is equal to -16. 4 times 0 is 0. I'm left with -16. So the y-intercept of equation 1 is 0. -16. We'll come to equation 2 later. But now we know what the y-intercept is for equation 1. Okay, now that I solved equation 1 for y, why did I do that? Because we just discovered they have two different slopes. They have a point where they intersect. So since they share that one common point, why did I solve equation 1 for y? What was the purpose and strategy for doing that? Why did I do that? Do you remember? Yeah, I need to get an equation that has one variable. So since I know that these two lines intersect are going to have a common point, are going to share one point in common, I can take this expression of y and substitute that into the second equation, since they both have that one point that they share in common. So now let me show you the substitution. So now drawing this line here, and please let me know whether the pace that I'm moving, if it's good for you. Here goes the second equation. I get -2x plus 3y equals 12. Now I'm going to use substitution. I know that from the first, y is equal to 4x minus 16. So I'm going to apply, I'm going to use substitution. I'm going to take that expression and substitute it in place of the y. Let me show you. So now I have -2x plus 3. Now in place of y, I put the expression for y, and that's 4x minus 16. So now I did my substitution. We said that y is equal to 4x minus 16, and the equation is equal to 12. Look at what we accomplished. We now have an equation that is in one variable, do we not? Do you see that? You sure? Okay, now at this point, now that we have accomplished and did our substitution, am I finished yet? Did I find out what x is equal to? Okay, so what do I need to do now? What would you do now? What do you see that needs to be done? Alan. Use what property? Joe? Both? Right. They said the distributive property. Do you agree with that? Yeah, first of all, we're going to multiply this expression by 3 using the distributive property. So I'm going to take that 3, I'm going to multiply it times the 4x, and I'm going to multiply it times that negative 16. That's the distributive property. So when I multiply everything through by 3, what are you going to have? What is the result of that? Okay, let's see. Right now I have negative 2x. 3 times 4x, that's 12x. And 3 times negative 16, that's negative 48. That is equal to 12. Okay, now what do you see? What do you see now? What would you do now? Tell me, what do you see? Yes, Ed, you're exactly right. Phyllis, yes, that's correct. I see it. What do you see? Yes, I agree with you. There are like terms here. What are the like terms? What terms here are alike? Yes, these two terms. The x terms are alike. I totally agree. So now we're going to combine those. So in this case, when two numbers are opposite in sign, we get 12 minus 2. These two negatives cancel two positives. We end up with 10x. So far I have 10x minus 48 is equal to 12. Okay. All right, now, am I done yet? I still don't know what x is, do I? Okay, what is the next step here? What is the next step here? Yes, I need to get the 10x by itself. So that means, can this negative 48 stay here? Can it? No, it can't. So I need to use the additive inverse. What's the additive inverse of negative 48? It's a positive 48. And then now, when I add a positive 48 to the left, I must do the same thing on the right. That is called the additive property of equality. So let's go ahead and show that. Let's show the use of the additive property of equality. So now I add 48 to both sides. Now that gives me 10x is equal to 60. Is that correct? Okay. What do you do now? What does 10x mean? What does 10x mean? Yes, that means 10 times x. I need to solve for x. So what do you do now? Harold? You're exactly right. You want to know what Harold said? What do you think Harold said to do? Very good. Yes, he said divide both sides by 10. Very good job. So let's go ahead and show that on the next line. So now I'm going to go with 10x divided by 10 equals 60 divided by 10. And now x is equal to 6. Very, very, very impressive. Very good.